Log exam practice question 9. Solve the following equation. So the first thing I'm going to do is get rid of this 3. So I'm going to divide both sides by 3. That makes my equation a lot simpler. Now one thing we know about the equal sign is that the equal sign is equivalent. Whatever we do to one side, we must do exactly the same thing to the other. So I've divided both sides by 3. It also helps us with understanding everything though, because if I do log base 10 on one side, I'm doing the same thing to the other. So I could rewrite this and put log base 10 of 1/3 to the power of x, and that is going to be equal to log base of 10, 0.0014. And we do this so we don't have to use a CAS calculator. We can use a normal calculator to solve for our power. So it's just something extra that we're able to do. So the next thing I'm going to do, I've got a power here. So I can take it out the front, and it becomes x log base 10, 1/3. I'm just going to rewrite that now as the same as 3 negative 1. Equals to log base 10, 0.0014. I've done it as to the power of negative 1 because straight away that tells me I can take a negative out the front. And then I'm going to straight away take that negative 1 and put it up the front here, negative x. Now I want log by itself, so x by itself. So to do that, I'm going to divide both sides by negative log base 10 of 3. And that gives me log base 10 of 0.0014 over negative log base 10 of 3. So I know that log base 10 of 0.0014 is negative 2.853. I've already just typed that into my calculator. Likewise, I know log base of 10, 3 is positive 0.47. That's timesing with a negative. So it is 0.47 negative. Now, if I divide that, the negatives cancel, and I get a positive for my x value, which my positive is 5.981. So that is my power. Likewise again with this side here with my next question. It looks complicated, but it's exactly the same thing is going to occur. We're going to do a log base of 10 on both of sides of our equation. So straight away I'm going to have log, because the log base is 10, I don't really put the 10 there, but I'm just going to. The log base of 10 is 5 times 2 to the power of t minus 1. And that is equal to my log base of 10, 2 times 5 to the power of 2t. So the next thing I would like us to think about is what happens when we are timesing. Well, if we're timesing, well, we're also thinking about our understanding of addition. So I can also separate that and go log base 10 is 5, and that is adding log base 10 of 2 to the power of t minus 1. And I then can go, it's equal to log base of 10, 2. Again, it's timesing, which means I am plussing, because think about our exponents. When we're timesing, we're looking at how many, we're just adding our exponents. So we're adding log base 10 of 5 to the power of 2t. This is starting to get a bit more simpler now. Now, straight away, this is where I'm going to start using my log calculator. So the first thing I'm going to think about here is I've got log base of 10, 5. And that is equal to 0.69. So 0.6989. The next thing I'm going to do, I'm going to take my t minus 1 out the front. So I'll do this part after. T minus 1. And I've got log 10 of 2 there. Then I've got equal to, well, log 10 of 2, I'm just going to do now. So log 10 of 2 is 0.301. 0.301. Then I've got plus log base of 10, 5 to the power of 2t. So I'm going to get rid of this 2t and put it out the front of my log. So 2t can go down here, and now I'm starting to make it look a bit easier. So I'm just going to simplify this now as 0.6989 plus, we know log 10 2, we've just done it over here, is 0.301. So I've got 0.301 times t and 0.301 times negative 1, which is negative 1 lot of this is 0.301. That is equal to 0.301 plus, again, log 10 of 5, we already know what it is. So it's 2t times this. So straight away I'll use my calculator and go 2 times 0.6989 is 1.3978. So it's 1.3978 t. We're starting to get a picture of where we are now. Now we just need to solve it. So to start off, I'm looking at what I can do to simplify it first. So I've got 0.6989 and I can take away 0.301. So 0.6989 take away 0.301 gives me 0.3979 plus 0.301 t is equal to 0.301 plus 1.3978 t. Now the best thing that we can always do is work on getting our t's onto one side and working out getting our constants onto the other. So I'm just going to take away my 0.301 t. So if I take away this on both sides, that just means make one less thing I need to do later. So that means on my left hand side I've only got 0.3979 now. I've still got my constant on my right of 0.301, but the amount of t's I've got, I did have 1.3978. I am taking away 0.301. That gives me positive 1.096t. Again, I'm going to get my constants onto one side, so I will take away 0.301 from both sides. So 0.3979 taking away 0.301 gives me 0.0969 is equal to 1.09t. 96t. Again, I need to get t by itself. So to do that, I need to divide both sides by 1.096, and that is going to give me what my t equals. So if I divide it by that, that gives me 0.088 as my value for t.